In this video, we will be talking about the last of our series about ray diagram. It will be all about concave lens. Now, we have to bear in mind that for concave lens, we will have only one case. I hope you see the pattern here. Let me sum it up first before we start for concave lens. So first we have plane mirror, the first video of our series about ray diagram. Better check it out if you haven't yet. And we have concave mirror, and we have concave lens. On the contrary, we have convex mirror, which was discussed in the previous video before this, and we have concave, this is supposed to be convex lens. You have to interchange this. So given that we have convex lens, we have concave lens. And that is exactly our topic for today, for this video. Let's recall, concave mirror, we have case 1 to 5. For convex mirror, we only have case 1. For convex lens, we have case 1 to 5. And for concave lens, you only have one case, which is just our case 1. So I hope you can see the analogy here. So just to keep you from sheer confusion, please refer to this legend. So concave mirror and convex lens, we have case 1 to 5. For convex mirror and concave lens, we have only one case. Alright, let's just make sure that we're on the right track. So we have plane mirror. This is the most basic representation or illustration of the ray diagram, our easiest lesson if my statement is not subjective. And our concave mirror, indeed, we have 5 cases. Our convex mirror, only one case. Our convex lens, we have 5 cases. And for concave lens, we only have one case, which is for today. Alright, without further ado, let's proceed to our very lesson. Let's put a divider. Alright, for concave lens ray diagram, we will be using a specific template, which is this. So one thing that you could that could help you remember that concave lens diagram is represented with this kind of mirror. Just try to remember that it looks like a Ben 10 symbol in his Omnitrix. If you watch Ben 10 during your childhood, you might have recognized the symbol, the shape at the center of his Omnitrix watch. So cartoon aside, this is the mirror. This is concave lens. Alright, so for case 1, just like our convex mirror, our object is at any position. And by that, what we call any position, we'll be assuming that the location is here, in between 2f and f, between the 2 times the focal length and the focal length. So given that, we'll still be using 2 colors, 2 pens. One is going to be mint green, one is going to be velvet red, but still, again, I've said this so many times already, but just for you to remember again, you could use any 2 colors to use so that we could graph our lines. So here, this is how we do the first line. So from that, it gets reflected. We pass through the focal point that is within the virtual side and extend to the real side like that. Let's move on to our next color, the next line. We intersect the point of origin. We're not going to intersect the focal point or length in the virtual side. We're going to intersect the point of origin this time. So there. And after that, it's unlikely that we still place a line there. So I don't think it's necessary anymore because this is what I've drawn. This is what I've used to review. I have another copy at my other iPad beside me, and this is what it looks like. So this is our intersection, and mark an arrow there. We can therefore conclude that the object is, by the way, before we proceed to that, again, dashed line at the virtual side. There you go. And arrowhead there. We won't be placing an arrowhead here anymore. Just let it be that way. The light source here, the eye over there. And yeah, that's all that we have to draw. Let's draw our conclusions. Object is virtual. We lack so much space there. Cut. Object is virtual. It is upright and diminished. We already know what we mean by diminished. It's smaller than the initial position, and it's upright because the arrow is going up. It's inverted if the arrow is going down, such that we have this kind of arrow. There you go. And it's virtual. We already know that the point is in the virtual side, not on the real side. So yeah, this is how we illustrate the concave lens ray diagram. This is all that we have to know, if I'm not really mistaken, because this is what we've studied during our previous quarter. And yeah, I hope this video helps in your exam. And yeah, thank you for watching.